Welcome to the Purpose Legal podcast. At Purpose Legal, we're redefining the way legal teams tackle challenges, offering solutions that are efficient, client-focused, and powered by advanced technologies. Join us as we dive into the topics that are shaping the legal industry today, sharing insights, strategies, and thought leadership to help you navigate complexity and achieve your goals. Let's get started.
So I'm Jeff Johnson, Chief Innovation Officer at Purpose Legal, joined today by Sergio Suarez, CEO and founder at TackleAI. Sergio, thanks for joining us today.
No, thanks for having me, Jeff.
So we spend a lot of time talking about AI in eDiscovery review. Personally, I spend a lot of my time talking about that, testing those solutions these days. I don't spend as much time talking about another sort of corner case aspect of that is that AI in reviewing media, images, audio files, bad images of text, photographs. And I wanted to spend a little bit of time, Sergio, talking with you today around specifically that image analysis, where we're talking about bad documents, where traditionally OCR might not have been great, the things we can do with that, as well as photographs. So as we jump into that, I wonder if you could just talk to us a little bit about what's better about the AI text extraction, if you will, that we can run today versus maybe previous iterations of AI, and certainly the OCR that we're all used to from decades in this industry.
Yeah, so for OCR has kind of been the same technology for a long time, since like the late 1970s, and they've been small upgrades as time goes on, but we're kind of fundamentally changing that now. And a lot of times when people talk about AI, or at least, in the last 4 or 5 years, they're referring to large language models. So they're referring to like the ChatGPTs and the Claudes and things like that. But although that's important and a lot of the stuff that we do at Tackle, in reality, most of what we do is computer vision. So unfortunately, right now, whenever people hear computer vision, they think of like cars driving themselves. But we use the same exact technology for reading documents. With OCR, it's expecting text. It's trying to guess the font. It's trying to guess font size. And it kind of expecting left to right reading, and a lot of times documents don't come like that. On a daily basis, we process about 250,000 medical documents, and they're all faxed. So we're having to deal with incredibly bad quality, and we had to do something to be able to read these documents back in 2018, 2019, and then throughout. We knew that OCR wouldn't get the job done, so what we did was focus on computer vision models that could actually read this without us having to try to clean the documents up too much or use too much old-fashioned OCR. So what we do is, we try to have models that look at a page and say, hey, is this a really, really clean document? If so, go ahead and use, your basic OCR on it. But if you see that there's noise, there's a lot of issues with the image quality, or it's clearly a fax, use computer vision. And that's what really kind of sets us apart from everybody in this particular space is we've been writing proprietary computer vision models for years. We're not just kind of using off-the-shelf things for computer vision. We have, dozens of models that we use for particular things and that really only work in legal and healthcare.
Thanks, Sergio. So I hear AI-enabled text extraction. I've heard multimodal mentioned. You mentioned tackle vision a minute ago. If you could just explain make sense of all of those words and explain how they fit together, that'd be fantastic.
Yeah, so I think with multimodal is really like the concept of using multiple types of AI to get done what you want to get done. So it's using computer vision, it's using large language models, reasoning a lot of times. So instead of just using a large language model, which is essentially really good at summarizing or guessing the next word, computer vision, or what we call tackle vision. There are models out there. There's something like Llama, which is a multimodal, and it has its own computer vision models that are kind of they're generic computer vision models. But Tackle, or what we call tackle vision, is we trained on legal and healthcare documents. So what we've done is we made all of our own models. So something that we noticed we would come across a lot in healthcare documents, for example, is tables. There was always tables of when you'd get a lab, you'd get, things that were spread out. And if you did OCR, well, the OCR doesn't know this is a table and that this is referencing this, right? Because it looks like they're very far apart and, that didn't really make sense. So we made models that just look for tables. And like, hey, I found a table, parse the table. Now find the header, find, how are these things identified? And then we're able to then understand tables. So something like regular, computer vision models that are out there don't really solve for that problem. So anytime someone didn't have something, we literally started from scratch. And we're like, hey, let's go get 100,000 documents that have tables and let's train a model to do it. We've done that dozens of times for a bunch of other things that we come across as well. So we basically put all of those models into something we call Tackle Vision. Tackle Vision excels on two different types of documents mostly, and it's things in the healthcare space and any type of legal documents that people send us.
Cool. As I try to translate all of those to use cases we could talk about today, one, early on as I looked at Tackle Vision, I saw an example document that was, I think it was a bad copy of like some notary statements, and I looked at the output, and not only was it very good text from a very bad copy, but in that particular use case, you had also written in the logic to actually pull data out. So there was a notary stamp on it, and it actually, there was a table of sorts that listed out the different contents of the notary stamp, as well as highlighting a signature from the notary public and actually what that signature was, what his or her name was. And sort of that translates into a use case that we've seen and worked on together. And that is, it was a large product liability matter. We were archiving hundreds of boxes, millions of pages worth of documents, and really trying to create sort of a quickly searchable index where we're looking at these documents and actually analyzing them, looking for key like province data, state data, as well as a date, and the ability for this technology to not only get the text, but also extract specific types of data and create that in a fielded format that we can use outside of that technology. And I know your medical records process does a very similar thing with the addition of document type detection. Care to talk a little bit more about that?
Yeah, I always tell people it's like for the longest time, people were always looking for metadata, right? Because they want it for search, right? That's why you want to know. You want to know that, hey, this is this type of document and it's this date, so that later you can say, I'm looking for these types of documents before this date or after this date or etc. Now with things like Tackle Vision, as long as we know what people want out of a data set, they give us a million documents and they say, hey, these are going to be, these are going to be some type of medical record, or these are going to be contracts about X or Y. It's really important to know whether they were notarized or not, and we'd like to know the dates of them, and we'd like to know. So people list out like 20 things that are very important for them. Tackle Vision goes through, and we have models for all of these things. The reason we were able to find the notary stamps was because we have a model that we trained on millions of notary stamps. And we're able to, now when it sees them, it knows them, and then it goes and sees what other information it has. So now the computer vision model will now give a language model information like, hey, there are two notaries or a notary stamp at the bottom of this, and there's a signature. There's also name underneath. Go grab the name. Right now, the part that does the OCR portion will go grab the information. What we're really doing is using what people refer to as agents, except kind of on a computer vision level for what we're building is once one model will go get information, give it to another model so that it can then go get information based on the information the other one just gave it. And then you just kind of continue down the line until you get all your data that you're looking for. And that approach has worked really well for us. We're not, I think a lot of people think that there's like one magic prompt that they can write and they will ask the question and get a one cohesive answer. But in reality, it's really supposed to be done in steps. A lot of times people do that because things like ChatGPT charge you for every prompt and every answer. So you try to pack in as much as you can to make sure you're not paying too much. Luckily at Tackle, we have all our own hardware. So we can ask up to, we ask 40 questions sometimes back and forth to make sure that we're getting it right.
Let's talk about using this technology to analyze pictures, photographs. I know we've done a few things in our usage here at Purpose, where we've been able to analyze photographs, looking for things like safety violations or construction issues, whether it's faulty construction or any other thing that we might be looking for in a construction matter that would be photographic type evidence, and you want the AI to find specific pictures, so you're not flipping through looking at all of the pictures trying to find that. Is that something that you've been working on at Tackle?
Yeah, so the major way we're used is to eliminate noise. And that's how I always think of AI in general. Is AI is really good at eliminating, our brains are really good at that too. I always explain people the concept of you driving towards like a wall. Yeah, you're very good at eliminating all the factors in your brain and just focusing on, am I going to turn left? Am I going to turn right? Or am I going to brake? Right. And you eliminate how hot is it outside, what noises you're hearing, like you get rid of all of those inputs. That's what we try to do. We try to do the same thing with our AI. So whenever we're analyzing images, a lot of times people will say, yes, we're looking for things of construction sites that have lumber on them, right? So then what we do is we look through all the documents and we return just the ones that have lumber, and they're part of a construction site. And sometimes, there could be 200,000 images, and we're going to give you back 3,000, and that's really what we're able to do that in like an hour instead of you're saying humans looking at documents for forever and ever. So that's really where we're used with the most is in healthcare. We literally can tell like, hey, this is a CT scan, this is an MRI. So usually we can then say there's probably some sort of progress note or some sort of a review of somebody who of this MRI or this CT scan. In legal, it's really about search. It's how do I get to the thing that I need the fastest. So we do that with metadata. So we'll look at a document and we'll tell you everything that's on that document. We'll say there's a tractor, there's mud, it's sunny, it's this date, it's all of this stuff, and we'll usually put it on a JSON file so that later on when you guys want to know, hey, I'm looking for the date between these months and at a construction site, it's very easy to search and get that information.
Very cool. We've seen some other implementations of this technology, and a lot of our partners implement them different ways and with different use case focuses. And building on technology similar to this, the ability to actually interface with the LLMs and identify, not only is there in the example I shared earlier, not only is there a safety violation here, but it's a violation of OSHA standard 123.7, obviously a made-up standard.
Yeah.
But it's just really cool what this technology can do, especially coupled with some of the other technologies that we provide from our partners. Well, Sergio, just as a parting question, I like to ask you, what do you see that's cool coming down the pike? What's Tackle working on that you can share?
Yeah.
Or even something you've seen somebody else working on just sort of out in the wild that you think is really cool and might make its way to our space?
There's a lot of things there's a lot of really interesting things going on around search and just making that faster. Cause I know in legal, a lot of times you have to search through, 400 million documents, and it's how do I categorize all of these quickly and not use, thousands of GPUs, which is kind of the brute force methods we're using today. I think a lot of it is coming from hardware of how are we going to be able to use large language models much faster. I know at Tackle, we're always, I think we're going to start seeing a lot more push towards computer vision and less large language models. We're getting pretty much, I feel that we're getting to where we're going to be with large language models, and we'll see incremental. We've been seeing giant leaps with large language models over the last 2 years. Those are starting getting smaller, but computer vision is really where the future is with the stuff that's going on, especially when it comes to spaces like healthcare and legal, because of the amount of documentation there is. And that doesn't go away. I think a lot of times people think documentation means paper. I'm like, we've created so many digital documents. You go to the doctor and you get a checkup, get 150 pages worth of information in, a 1.5 hour time period. And 90% of that is useless to you, the patient, or useless to you, the legal expert that wants to review, something about a case. So I think mostly what we're going to start seeing is a lot of customization around niche AI. So right now we have very general purpose AI. So like, the ChatGPTs, Claudes, DeepSeeks. You're going to start seeing more companies like Tackle that build models specific to an industry. Things that the larger the models get right now, they keep getting bigger and bigger. Doesn't mean they're getting any better. It just means they hold more information. And I think, I've always felt that economies are made up of specialists. And I think you're going to start seeing people who are experts at things like uh, again, healthcare like us, legal. You're going to start seeing fintech, where it's just a large language model that just knows fintech documents, or only knows these specialties. We're going to see more and more of that moving forward because the amount of accuracy you get by doing that is exponentially higher than everyone else. That's why, like at Tackle, we have a lot of competitors that are ChatGPT wrappers, and I love when they compare the two of us. People, hey, well, what about these guys? I'm like, use them, and then use me, and then you'll realize the huge difference. That's always my best advertisement is go use them. It's great. I like them as people, but so yeah, I think that's where I think the future really is computer vision and niche models built from the ground up that are good at one specific thing.
Fantastic. Well, thanks a lot, Sergio.
No, thank you, man. Anytime you need, come on. We'll talk about AI. It'll be fun.
Fantastic.